Okay, so today we're going to start our focus on looking at graphs and specifically linear graphs. And so we're going to start with some things that you've probably seen before. We're going to start with some picture patterns, but then that's just going to give us our data points. Then we'll start moving from there to our and start really refining our knowledge about graphs. So the first thing I want to talk about is just what a linear relationship means. And if you think about it, what is the root word for linear? Line. And that's what we're talking about. We're talking about data that if you put it on a graph, you would end up with a straight line. Okay? So if you do the data and you put it on a graph and it doesn't come out to be a straight line, what can you assume? Well, if we're studying linear functions, then right now, if you do it, then you can assume that you've made a mistake. Okay? So make sure that they're always going to be straight lines. This gives you a little bit of a clue. So let's go to our Education Perfect and look at some of these linear relationships. And they start off talking about different kinds of tables and different kinds of things and patterns and rules that you can use. So you can have a spatial pattern where they give you the pattern in pictures. You can have a table, right, with n values and t values. You can have a sequence of numbers where you're supposed to find the pattern, or they could give you a rule, which is written as an algebraic expression, or an algebraic equation, I should say, that will give you the rule for any number in the pattern. So you can have these types of things presented in lots of different ways, and you've seen all of these, right? You had in your problem solving, you did the number patterns, and you learned how to write the 2n plus 1 and all of those types of ways. So what we're going to do now is we're going to focus on yet another way of describing these patterns. We're going to be able to draw a picture of the information. So, anytime you have a pattern, remember, a couple of things have to be true. First of all, that you can't just interchange the numbers, right? So in this particular table, if I have an n of 1, what is the only possible number that can be paired with that 1 in this case? The 3, right? It's 1, n is 1, then t has to be 3. They cannot be interchanged, okay? So, for this particular pattern, if n is 3, what number goes with the 3? In this particular pattern. All I'm asking you to just read it off the chart. 7, right? Okay? So, if n is 4, what does that make t? 9, right? So, those numbers are linked together and cannot change. They have to be together, okay? So you need to make sure that you're not changing the pattern when you're working with these. There's a relationship between the number of the term and the term itself, okay? So don't have one without the other. They have to be the same, okay? Now, in this particular rule, you can see, if you look at your t's, that what's happening is every number here is increasing by what? By 2. So do you see that there's a distinct pattern for that? This makes it a linear. So when you have some relationship like this, where it's just a continuous pattern, then what you're getting is something called a linear relationship. That tells you that if you plotted these on a graph, that you would always get a straight line. Okay? All right. Because they always change by the same amount. So this graph is an example of what's called the Cartesian plane. Hopefully it's not brand new to anybody, but even if it is, we're going to talk about it. First thing about the Cartesian plane is that it's made up of, two number lines. And if you look, there's a horizontal one. Horizontal means it's flat, right? And there is what's called when it goes straight up and down? A vertical one. Excellent. Okay? And you'll notice that they're labeled. In this case, this one's labeled with N, and this one is labeled with T. Now that's because our chart has numbers that are labeled N and T, but can anyone remember the traditional values for these for just a generic chart?
X and Y.
Right. Usually the horizontal one is X and the vertical one is Y. But if you have specific information like time and, growth, then you can use different letters. So you don't have to use X and Y. But what you do have to remember is that every one of these intersections of lines represents a different point on the graph, right? And so it's made up of two number lines. Let's talk about their intersection first. They intersect where they both equal 0. So if you see this point where they're crossing right here, notice that that's where on the number line, if you're looking at the number line, you would end up with a 0 at both of those places. Okay? So that point is something called the origin. Now, it's called the origin because that's where everything originates or begins. So if you're going to be graphing using the Cartesian plane, where do you know that you're going to always be starting? At the origin, right? So origin is simply another way of saying the start. Okay? So it's two number lines. They intersect where they both equal 0. The horizontal axis, and each line is an axis, so this is just an axis here, right? So the horizontal axis, or number line, is usually called the x-axis. But it doesn't have to be. You can use different letters depending on the information that you're given. So if it's information specific, then you can use that information. We also have the y-axis. And that vertical axis is called the y-axis. And those letters will always tell you which directions you're moving. So if it's an x number, the x value tells you to move which direction? Across, horizontally, right? The y one tells you how far you're going, what? Vertically, which means either up or down. Yeah? And it depends on the signs of the numbers which ones you're doing. So make sure you know each one of those. So here, in this particular case, we moved to the right 3, but then we also moved, to get to that dot, we also had to move up what? 3. And that's what's called an ordered pair. And they always come in order. That's why they call it an ordered pair. And it's simply alphabetical order, x, comma, y. And there are always 2 of them, which is why it's a pair. So your ordered pair. Okay? So the ordered pair for that particular one is 3, comma, 3. Because we moved to the right 3 and then up 3. Right? Sounding familiar? Okay, good. So every one of these numbers in our chart can be plotted on the axes. And again, they're using N and T, but it doesn't matter. You can use whatever you want. So what I'm going to do is I'm going to write these from the chart in the form of ordered pairs, and then we're going to plot them. So 2, 5, written as an ordered pair, would be just 2, comma, 5 in a parentheses. You have to separate them by a comma, and it has to be enclosed in a parentheses. Otherwise, you can't tell that it's an ordered pair. It just looks like a list of numbers, right? So they're always going to be written in that format. Okay. Now I've moved it, so I don't know what my numbers are, but maybe you can see them. So what did we have? We had 2, 5, 3, 7, and 4, 9. So looking at our plot, again, starting at the origin, if we're going to do 2, 5, we're going to go to the right 2, and then what? Up 5. And that's where our ordered pair will be plotted. So make sure that even though it has 2 numbers, it only gets 1 dot, right? And our next one was, anybody remember? 3, 7? There we go. So that means to the right 3, and then up 7. And then finally, we had 4, 9. So that means to the right 4 and up 9. And what do you notice about all those dots? They're all lining up in a straight line, yeah. And so we can actually just connect them all with a straight line. Okay? Good deal. All right, and they've just plotted them out and then connected them with a line. Yes?
With the line, do you keep it going past the points, or do you end it at the first and last point?
These things are infinite. So with the line that you create, you'll notice what happens with the line that you create is it always continues along where the graph, at the edge of the graph. Now, if you notice here, they've only done part of this. This is what's called the first quadrant, this corner. So they're not interested in what's happening down there. So they're letting the line stop right here. But we'll see that sometimes if you include all 4 sections, then it has to continue straight on. So, for example, let's say I had both number lines, the whole thing. If I was going to draw a line, it needs to go all the way from one edge all the way to the other edge. Okay? Because it goes on infinitely in both directions. Now, they're not showing infinite in this direction this time because they don't have the rest of the graph on there, right? So if you don't have the rest of the graph, then your line will stop. But here, these lines, see how they just seem to continue on? So that means that you need to make sure it goes from all the way from edge to edge. Okay? Good question. All right. The messy drawing. Good question. Okay, so here's what I want you to do. Just want you to take a second and think about, just draw a little sketch of this. Because you don't have this on your right in front of you, but just draw a little sketch and see if you can plot some of these things. This one's pretty easy because the numbers are the same. So if you want to just call them out. So who wants to do the first one? Tell me what to do. Anybody? Sure.
You have to go down to for the numbers across, you have to take the one that's below it.
Okay. So, right. So that means that number and those numbers are linked together. Exactly. Excellent. Good. So tell me then, if I'm starting at the origin, that for top number n tells me I need to go where?
Up? No, down. No, you said
Across first. All right. And so I'm going to go to the right one, and then what?
right one is that.
And then the t tells me to go
Up.
up. How many?
1.
1. So to the right 1 and up 1 is going to give me a point right there.
Yeah.
Okay? Good. Excellent. Okay? So who wants to tell me what to do on the second one? Sure.
Yeah, you go horizontally twice.
Okay. But one thing that you want to do and make your life easier, because right now all we have is horizontal and vertical, right? But think about it. When we start adding all of them in there, you can go not only right, but also what? Left. So let's use very specific terms. So I need to go to the right. How many?
2.
2, and then what?
Then you go up 2.
Up 2. Okay? So be very specific. It's right or left, up or what? Down. Now in this case, because I only have that one section, all it can be is right and what? Because there is no left and down on this graph, right? But again, remember, build good habits now, and then it'll take you on with your next one. You want to do the next one?
I had a question.
Oh, sure.
If you move to the left or down, would it start going into the negative?
Exactly. Then that's exactly what will tell you what to do. So if it was a negative 2, that would mean to the left or down 2, depending on what the position it was in the original. Okay? All right. Now, I'm not going to do all of them. Let's just do the last one. So somebody want to tell me what to do on that one?
You go long and up.
Well, the numbers are 5 and 5, right? So I'm going to go to the right 5 and what? Then up 5. Excellent. Okay? And you notice what's happening to the dots? They're all lining up in a straight line, right? So we'll just draw a line through them. Do I stop it there?
No.
Nope. Remember, it goes on infinitely, so it goes all the way through the graph, all the way to the other edge. Okay? How easy is that? If you can count, you can graph.
So you do not do all of them, you just do...
Oh, well, we just did 3 of them. We don't have to, right? Okay? Do you need all of them to do a line?
No.
Nope. If you're really good, you only need how many dots to make a line? 2, right? But I would typically try to use 3 because what happens if you get one of them wrong and you only use 2? Your line can be doing this when it's supposed to be doing what we did, right? So be very careful. Most times you want to use at least 3 unless you're just positive that you're being very careful. Good job. Okay. So here we go. Here we have another relationship. Let's see if I can get it all on there so we can see. Again, the N tells you how far to move either to the right or left. The T is going to tell you how far to move up or down. And when you do those, they should be in a straight line. And since that's in your homework, I'm not doing it. Y'all will. Okay? So, but just notice that the numbers get bigger. Is that going to change the way you do it?
No.
Nope. You're just going to count them out. Always right or left first, and then up or down. Okay? Good job. So you've seen the Cartesian plane before, I'm thinking. Yeah? And worked with it before? Good. All right. Now let's see what happens when we're not given the actual values, the number values, but instead we're given a rule. This rule is a rule for a linear function, a linear rule, and what we can do is we can find what numbers we need by simply creating a chart ourselves. We're not given a chart, but we can create one. So, in general, doesn't matter which way you go. I don't know why, but for me, I just like for my charts to go up and down. They like for them to go across. It doesn't matter. But I'm going to need an N, and I'm going to need a what? A T. Right? Yes?
It says this rule tells us the term.
Right. It tells you that it's 2 times the term number, and then minus 1, right?
It's an error. It says this rule tells us the term.
Oh, I'm sorry. There we go. How's that? We need to report those. Okay, so now what I can do is I can choose any numbers I want to. Because remember our line went on forever? That tells us that these things are infinite, right? So it doesn't matter what numbers you choose. So I'm going to choose 5,639, right? Because that'll be an easy graph to draw, won't it? No. You don't want your numbers to be huge because it doesn't make any sense to have big numbers when small numbers work just fine, right? So don't get too creative. Use small numbers. And generally, we like to use 0 and 1 and 2, right? Because they're just easy to use, right? You can just use 1, 2, and 3, whatever you want to use. And what we're doing is we're always going to we can use either T's or N's, but if you'll notice, all the math we need to do is over there on the N side. Do you see that? So if that's the case, then that means it's going to be easier if we choose N values instead of T values. Okay? What if all the math was over here with the T? Then it would be easier for us to choose T values than N values. You see the logic there? So it doesn't really matter. Technically, it doesn't make the slightest bit of difference. But you want to make your life easier, right? So let's just pick some. So what do you want to choose? We could choose, I don't know. I don't have any favorite numbers, but I might choose 0, 1, and 2. Do you have to choose 0, 1, and 2?
No.
But, why not choose easy numbers? Yeah? And I picked 3 of them in case I make a mistake on one. Because if you make a mistake on one of them and you only have 2, then your line's going to be going in the wrong direction, right? But if you make a mistake on one of them and you have 2 good ones, then they're not going to line up in a straight line, which means you automatically know that you've made a mistake. So all we need to do is first choose any 3 numbers. Right? Doesn't matter what they are. Then we're simply going to substitute those into the rule, which is why we looked at substitution last time, right? Substitution means plug in the numbers and then evaluate. Evaluate means to simplify it or do the math, right? So that's exactly the lesson we had last time. So t equals 2 times our first number, which is 0. And why I always choose 0 is because 2 times 0 makes what?
0.
So it just makes the n term completely disappear. Right? So t is what? Minus 1. Now, you can get negative numbers when you do that, so it might not fit if you just have that one side of the graph. I'm not sure what they do, but it doesn't matter. We still know that's one of our valid numbers. If t is 1, then 2 times 1 minus 1 gives me 2 minus 1, which is 1. So if n is 1, t is 1. Then if t is n is 2, that means t is equal to 2 times 2 minus 1, or 4 minus 1, which is 3. So we have 3 values, right? And again, this one might fall off our graph if they're just giving us the other one. I haven't done this lesson, so I'm not sure if they give us just the 4, but we'll see. All right. So all I did was choose any 3 numbers. And again, it doesn't matter which ones. I like to use 0 because it's easy. Just makes your n term disappear, right? Okay. So substituting that, they made a chart. They just made their chart. They started with 1, which probably means they're only going to give you the positive values, which is fine. And then they used 5 values. Do you have to use 5?
No.
But you need to at least use
3.
3. Good job. Okay? So they did that, and just evaluated each one of those to get the rest of the chart, just like we did. And then they gave us a graph. Okay. So now I know why they chose 1. Why? They didn't do any negative values, right? It would fall off the chart a little bit if you did that, so we don't care. All right, so then they just did the chart. What do you notice about all those values? They line up in a straight line, which they have to. What if one of the values that they got, you plotted one of your values and it was over here? Then you can assume that one was done incorrectly because it doesn't line up. So it's an easy way to check. Okay? Good. So they plotted the points and they all line up. So what I want you to do now then is get out your paper, or you can type it in. What do you want to do? Paper is better. You should have a math notebook anyway, right? So, and I want you to choose any 3 values and give me 3 values for this one. Go. You've got 1 minute. Yeah, 1 minute's plenty. 3 values for this. Okay, so the last part is simply to draw the line. Make sure that you're drawing the line all the way to the outside edge of the graph. Don't just stop at the dots, because that's not a line. Do you remember your geography? That's a line segment, right? A line goes infinitely in both directions, right? A line segment stops and starts at a specific point. So we're drawing lines, not line segments. Looks good? Okay. Then